On October 2nd, 2025, the HiRISE camera aboard Mars Reconnaissance Orbiter photographed 3I Atlas at a resolution 3 times sharper than Hubble. Those images were not published for 40 days. No statement. No acknowledgement. The tracking page went quiet. The Minor Planet Center confirmed the pause. And the object, the third interstellar visitor ever recorded in human history, continued on its trajectory while the most detailed images ever taken of it sat somewhere in a processing queue, or a server, or a bureaucratic hold. We still do not know exactly where. What we know is the number, 40 days. And we know what was happening during those 40 days, which is what I want to walk through here. To understand why that number matters, you have to understand what we were actually looking at. The 3I Atlas was formally designated on July 2nd, 2025, roughly 48 hours after the Atlas telescope at Rio Hurtado, Chile, submitted its detection to the Minor Planet Center. Within hours, archival searches found earlier observations. The Zwicky Transient Facility at Palomar had data going back to June 14th. TESS had picked up possible cometary activity even earlier, in May, when the object was still 6.4 astronomical units from the Sun. It had been hiding in the star fields near the galactic center, which is part of why it was caught so late. By July 2nd, 122 observations from 31 separate observatories had already been submitted. David Jewett at UCLA confirmed the object was clearly active, a genuine comet, not a dead rock. The coma at peak measured 26,400 by 24,700 kilometers across, roughly twice the diameter of Earth, just the gas cloud around the nucleus. The orbital eccentricity came in at 6.141. For reference, Oumuamua was 1.2. Borisov was 3.4. An eccentricity above 1.0 means the object is unbound. It came from outside the solar system, and it is leaving. At 6.141, 3I Atlas is moving on a trajectory so hyperbolic it is almost a straight line on the scale of the solar system. It entered from the direction of Sagittarius near the galactic center, the opposite direction from where the Sun is heading, unlike either of the two objects that came before it. It was, by every measure, unprecedented. The government shutdown began on October 1st, 2025. That same week, 3I Atlas made its closest approach to Mars, 29 million kilometers, on October 3rd. That is close enough for the HiRISE camera on Mars Reconnaissance Orbiter to image the nucleus at 30 kilometers per pixel, 3 times the resolution Hubble had managed in July. The best look anyone was going to get at the physical structure of this object before it crossed Jupiter and left the inner solar system permanently. The images were taken October 2nd and 3rd. They were not published. NASA's public communications were frozen by the shutdown. The 3I tracking page stopped updating. The Minor Planet Center noted the gap. There was no official explanation because there were, officially, no NASA employees authorized to give one. The shutdown lasted approximately 40 days, from October 1st to around November 11th. And the 40-day silence over the HiRISE data maps almost perfectly onto that window. Almost certainly, that is the whole story. A bureaucratic freeze at the worst possible moment in the observational calendar. That is the mundane explanation, and it is probably correct. But consider the pattern, because this was not the only data that went quiet. While NASA was locked out of public communications, other agencies were not. On October 7th, the European Space Agency's Trace Gas Orbiter released its first image from the Mars flyby. China's Tianwen-1 mission, equipped with the HiRISE camera, also captured the object and published its data while the shutdown was still in effect. The European and Chinese space agencies had no communication freeze. They observed the same event from similar distances, and their data went out on normal timelines. NASA's data from the same window did not. On November 3rd, Congresswoman Anna Paulina Luna of Florida sent a formal letter to acting NASA Administrator Sean Duffy, demanding the release of the HiRISE images. That letter is a matter of public record. It was not a Reddit post or a podcast rant. A sitting member of Congress formally asked NASA why the highest resolution images of the third interstellar object ever detected had not been made available to the public. Does that seem like a normal sequence of events to you? The shutdown ended around November 11th. NASA held a press conference on November 19th and 20th and released a package of data. Images from SOHO, Mars Reconnaissance Orbiter HiRISE, the Perseverance rover, MAVEN, and PUNCH. The HiRISE images were in that package. Nicola Fox, NASA's chief science officer, stated that the object posed no threat to Earth. It was at least twice the Earth-Sun distance away at closest approach. Amit Kshatriya, who leads NASA's Moon to Mars program, was candid about the gap. He said he was frustrated that the whole world had been speculating while NASA could not speak due to the shutdown. That is a reasonable and honest thing to say. The shutdown explanation is documented, official, and uncontested. I am not suggesting otherwise. What I am pointing out is that NASA's explanation addressed one layer. But there were 3 layers of silence running simultaneously, and the press conference collapsed them into one. The shutdown accounts for the HiRISE delay. It does not fully account for what came after. While the institutional silence was unfolding, the scientific data that was being collected and slowly released was building its own separate story. Webb's infrared spectrum, taken August 6th, showed carbon dioxide as the dominant volatile, alongside water ice and carbonyl sulfide. The mass loss rate measured 150 kilograms per second. The gas ejection velocity was approximately 440 meters per second. These are numbers you can model, check against known comets, and compare. The nucleus rotation period before perihelion was 16.16 hours. After perihelion, according to Hubble observations and ground-based data compiled through early 2026, it had dropped to approximately 7.1 hours. The nucleus more than doubled its rotation rate during the close solar pass. There are mechanisms that could explain this. Outgassing torques, asymmetric jetting. But it is at the outer edge of what has been documented in cometary physics. The anti-tail was tightly collimated, with a length-to-width ratio of approximately 10:1 and an opening angle of 6 to 8 degrees. Jason Wright at Penn State, who has been a careful, skeptical voice throughout, acknowledged the feature was anomalous, but argued it remained within the range of explainable cometary behavior. He may well be right. The nickel-to-iron ratio in the spectroscopic data was significantly elevated compared to known comets, including 2I Borisov. The nickel-to-cyanide ratio, nickel relative to cyanide, was off by orders of magnitude. Wright's partial explanation involves chemistry at large solar distances. It is plausible. It is also unresolved. David Farnocchia at JPL detected a non-zero non-gravitational acceleration during perihelion, based on ALMA data. Avi Loeb at Harvard's Galileo project has published more than 11 papers on 3I Atlas, and has argued, with supporting calculations, that the minimum mass consistent with the observed outgassing and the absence of earlier non-gravitational acceleration exceeds 33 billion tons, implying a nucleus larger than 5 kilometers. Hubble's upper bound is 5.6 kilometers. The numbers nearly touch. That discrepancy has not been resolved. Each of these anomalies has a plausible conventional explanation. What is harder to explain is why they keep accumulating in the same object. Here is what the timeline actually looks like when you lay it flat. October 1st, the government shutdown begins. October 2nd through 3rd. The best observational window of the entire flyby. Mars at 29 million kilometers. HiRISE running at full resolution. NASA goes silent. October 7th. European Space Agency publishes. China publishes. November 3rd. A Congresswoman files a formal demand. November 11th. Shutdown ends. November 19th. NASA holds a press conference and releases the HiRISE images, 7 weeks after they were taken. That is Layer 1. Layer 2. Parker Solar Probe observed 3I Atlas with its WHISPER instrument from October 18th through November 5th. Approximately 10 frames per day during that window. Those images are still being processed as of this recording. The final processed dataset has not been published. That is not a shutdown issue. That is a pipeline. Layer 3, the ION Coordinated Observation Campaign, which ran from November 2025 through January 2026, has not been published in full. The European Space Agency's JUICE mission captured data in November, but the spacecraft was using its medium-gain antenna as a heat shield. The data arrived on Earth in February 2026, and analysis is ongoing. And now, as of March 16th, 2026, 3I Atlas has passed Jupiter at a distance of 53.6 million kilometers, roughly equal to the radius of Jupiter's Hill sphere, the last major gravitational landmark in the solar system. Beyond this point, the object is effectively gone. The Parker WHISPER data has not come out. The JUICE analysis is not complete. The full AON dataset is still in processing. 3 independent sources of data. 3 separate delays. 3 different reasons. All pointing to the same gap in the public record. Right at the moment the object is passing out of reach for the last time. There is almost certainly a mundane explanation for all of it. Institutional inertia, processing backlogs, underfunded teams working through enormous datasets. That is the most likely answer. But the pattern is documented. Every delay I have described is sourced. NASA acknowledged the shutdown gap on the record. The congressional letter is public. The processing timelines are confirmed. None of this requires interpretation. It is just the sequence of events. 3I Atlas is leaving the solar system. It will not come back. Whatever its origin, a molecular cloud near the galactic center, a planetary system around a star we have not identified, something we do not have a model for yet. It has been here once, and only once, and the window is now closed. The data that is still in processing will come out. Parker WHISPER will be published. The JUICE analysis will be completed. The ION campaign will eventually appear in peer-reviewed form. When those datasets are released, what do you think we are going to find?